Okay, so this is the Unit 2E handout. And in this one, this is really a problem where you're just trying to justify statements that come up. And the way that this works is they kind of work like mini proofs. So we've done problems now that look like this, where you kind of have to come up with the reason that goes there. And this was actually a homework problem. This is the answer to the homework number 1 on 2D. So another way of reading this like mini proof is to change it into an if-then statement. And it would be, if this part's true, then you can say that that part's true. So if RS is perpendicular to TU, then the measurement of RTU is 90, because that's what perpendicular lines tell you. That's the definition of perpendicular lines. So in the type of problem that's in number 1 here, you're given these if-then statements, and really what you have to do is think of them as the mini charts and figure out what's the reason that goes with the second line. So like part A here, the way that you could interpret part A is like this. I'll put it over here on the side. So it's like a mini proof that looks like this: statements, reasons, and it's, yeah. So let's see here. In fact, let me move this page over first. So I got more room. So it looked like this: statements, reasons. If measurement of FOA and DOF are 180, so that would be, if this is true, FOA plus DOF equals 180, for whatever reason, then FOA and DOF are supplementary. So FOA and DOF are supplementary. So the goal is to find the reason that goes here. Oh, sorry. So let's go back and look. What we want is something that says 2 angles added together equal 180, so you can call them supplementary. So if we come back to our reasons page and go through some of them and try to find 2 angles that add up to 180, give you supplementary angles. Here's one that says 2 angles are 180, but there's no mention of the word supplementary anywhere, so it's not this one. But if we come down a little bit further, here we are. 2 angles add up to 180, so you can say that they're supplementary. That's the definition of supplementary angles. If I come back to here, it says the same thing. 2 angles add up to 180, so I can call them supplementary because of the definition of supplementary angles. So then the next one here says, if an angle is 90, then the lines that form it are perpendicular. And you can kind of look at the picture if you wanted. COD is right here. If this is 90, well then, yeah, FC ought to be, this ought to be perpendicular to that. But we need a reason to go with it. So that's where we go back to our reasons list and try to find something that starts out with 90, some angle is 90, and you get perpendicular lines. So all the perpendicular ones are on this page. And here's one: start with 90, get perpendicular lines. So that's the definition of perpendicular lines. So that's what we're going to put over here. Definition of perpendicular lines. C says you start out with a midpoint, and so one little part equals another little part. If O is the midpoint of this, AO equals OD. Right? Well, if we go back to the reasons list, the midpoint stuff is all up here. So this one says you start with a midpoint, and one side is the same as the other side. That's different from the midpoint theorem. You start with a midpoint, one side is half of the whole thing. So this is the one that we want here. So that's definition of midpoint. The next one says, well, you got the midpoint, but one part is half of the whole thing. And if we go right back to here, that's what this one says, midpoint theorem. Okay, let's try the next one. If OB bisects AOC, then you get angle 1's congruent to 2. So it should start, the mini proof should have this line first, the bisector first, and then congruent angles second, 2 angles that are the same. So let's see. Bisector choices are definition and angle bisector theorem. They both start with the bisector, but this one says one angle is half of the whole angle, so it's not the theorem. Whereas this one says you have a bisector, so one angle is the same as the other angle. So that's definition of angle bisector. Okay, part F says, where is F? If FOA, this one, is congruent to FOD, this one, so these two angles are the same, then FO is perpendicular to DA. Okay, so it's something about if congruent angles, then perpendicular sides. So let's come over here, and all the perpendicular ones are on the third page here. This one says if perpendicular, then 90 degrees. That doesn't really say the same thing. This one says if perpendicular, then you get congruent angles. And it says if you have perpendicular lines, then you get congruent adjacent angles. And if you go back to that picture over here, it's the same deal. If these are perpendicular, oh no, I'm sorry, I got this backwards. If congruent, then perpendicular. So it's not this one. It's the reverse of this one. It's 13 instead. So 13 says if you have congruent angles formed by two lines, then the two adjacent angles that are congruent, then those lines have to be perpendicular. So this is the reason that we want this thing right here. Two lines form congruent adjacent angles, then you get perpendicular lines. Two lines form congruent adjacent angles, then you get perpendicular lines. Okay. G says start out with two angles that are the same size and right next to each other. And so then this is a bisector of the big angle here. So we start out with equal angles and get a bisector. So bisector stuff is way up here. It's 3 and 5. So let's see, we've got a, what was it again? We started with equal angles and ended up with a bisector. So here are some equal angles and end up with a bisector. Definition of angle bisector. Okay, now H through K don't have ifs and thens. But notice an if-then in a proof starts out with this is the if part and this is the then part. If it doesn't have an if and a then, then it's really just the then. There's no if needed. So that would just show up in a proof like this. There'd only be something here. These steps wouldn't matter, right? And if you look at the picture for H, FOA is right here. AOC is right here. And it says add those two angles next to each other and get the big angle, which is 180, right? Well, anytime you add two angles next to each other, you get the big angle. That's the angle addition postulate. In this case, it's the special case. Right? Now you can go back to the reasons and find it. Angle addition postulate is right here. Notice there's nothing that comes first. It's just if two angles happen to form a straight angle, then you can just say to add them up, get 180. A lot of students confuse it with this one here. But this one's an if-then. If two angles are supplementary, then they add up to 180. That's definition of supplementary. If two angles are supplementary, then they add up to 180. If we look here, it doesn't say if two angles are supplementary, then you can get 180. It just says the two angles are already 180. That's it. Okay. Hopefully you're able to look at I and just know you're adding this segment to get the whole segment. That's segment addition postulate. So hopefully that one's stuck from last unit. J is slightly trickier because we haven't really used it in a proof yet. And actually, we won't use it for a while, but this one is useful. It's EOD, which is this angle, ODE, which is this angle, and DEO, which is that angle, all add up to 180. Well, they're the three angles of a triangle, so they ought to add up to 180. And in the list, It's way down here at the end. It doesn't even have anything listed for it, but it's just triangle is 180. It's phrased a little more formally here, but this is how I abbreviate it. So triangle equals 180. And then the last one, FOA, that's this angle, is the same as COD, which is that angle, and you might be able to tell those are vertical angles. And if you come over here, what reason is that? There it is, 11. Vertical angles are congruent. As long as they're vertical angles, you can just immediately say they're congruent to each other. So this one is vertical angles are congruent, just like that. And then that's it. Okay. So in number 2, this is a lot like the number 1 on your previous homework. It was saying, what could follow AO is perpendicular to FC in a proof? So it's using this picture here. So AO, the idea is that this one is perpendicular to this one. What are some steps that could come after it? So let's find some steps up here that start with perpendicular, right? So the ones that start with perpendicular are this one, and let's see, what else starts with perpendicular? And this one. So those are our 3 possibilities to work with. So let's take a look at the first one. First one says, if you have perpendicular lines, then you get a 90-degree angle. And you can pick any of those 90s and put it there. And the reason is definition of perpendicular lines. So I'm going to come back over here and pick one of these angles. I'll pick, what letter is this? A. So I'll pick AOF and say measurement of AOF equals 90. And the reason is definition of perpendicular lines. Let's go back and look at a different reason. So here we've got AC is perpendicular to BD. So AEB is congruent to BEC because perpendicular lines give congruent adjacent angles. Okay, so we got to pick the two of the right angles next to each other, congruent and adjacent, and just say that they're congruent. So in this case, we'll pick FOA and AOC. Right? So angle FOA is the same as angle, what did I say, AOC? Yeah. And the reason is perpendicular lines give you congruent adjacent angles. And then there's one third type of reason. There's a third one here, this one. So if 2 sides are perpendicular, then the angles inside are going to be complementary. This one we've talked about in class a couple of times now. So let's go back to here. 2 sides are perpendicular. So which angles are complementary? Let's just stick to this side here, right? So angle 1 and angle 2 are going to be complementary. Angle 1 and angle 2 are complementary. And the reason was the same thing that was phrased on the reasons list. If the exterior sides of 2 adjacent angles are perpendicular, then you get complementary angles. Okay, and that's it. I hope that helps a little bit.